Most of us don't think twice about our hair. We cut it, wash it, style it, maybe even complain about it. But if you actually stop and think about it, there's something kind of weird going on. Humans are mammals, but compared to basically every other mammal, we're almost completely hairless. Except for a few places, but one we clearly didn't lose it, and that is on top of our heads. And not only that, we grow it long, we maintain it, and our scalp constantly produces oil just to keep it healthy. So the real question is, why do we even have hair anymore? And more importantly, why didn't evolution get rid of it completely? Imagine an early human out in the open plains of Africa. It's hot, no shade, middle of the day. They're not sprinting, they're running, slowly, for hours, tracking an animal that's starting to overheat. And somehow this human could just keep going. Part of that comes down to something we don't usually associate with survival at all. The way our bodies handle heat and the hair on our heads. In this video, we're gonna dive deep into the dynamics of our hair, the evolution of it, and how entirely it came to be. Well, let's strip this down to the basics for a second. Hair isn't alive in the way we usually think. What you see, what you cut, that's already dead material. It's made mostly of keratin, the same protein your nails are made from. The real activity is happening under your skin. Each strand grows out a follicle, and at the base of that follicle, cells are constantly dividing, pushing older cells upwards. As they move up, they harden, lose their nucleus, and turn into that hair shaft. That's why you can cut your hair without feeling anything. Hair also grows in cycles. Anagen is the growth phase that lasts about 2 to 7 years. Catagen is the transition phase where follicle shrinks. And telogen is the resting phase where hair falls out. At any given time, about 85 to 90% of your hair is actively growing. The rest is resting or shedding. Now here's something that surprises a lot of people. Humans didn't really lose their hair in the way people think. We still have about the same number of hair follicles as chimpanzees. The difference is, most of our hair is thin and short, basically almost invisible compared to thick fur. So evolution didn't erase hair, it just sort of scaled it down, which raises the bigger question. Why exactly? The answer mostly comes down to one thing, and that is heat. Early humans weren't the strongest animals, nor were they the fastest. But they developed something that's actually pretty rare. They could keep going, longer than almost anything else. There's a hunting method anthropologists talked about called persistence hunting. Instead of chasing something down quickly, humans would just tail it, or follow it. Jogging, walking, tracking, tracing, hunting, for hours. Eventually, the animal overheats and would collapse. And that only works if you don't overheat first. Most animals rely on panting to cool down. Humans rely on sweating. And sweating is incredibly effective, but only if it can evaporate. If you've got thick fur covering your body, sweat just sits there. So over time, natural selection started favoring humans who had less body hair, more sweat glands, and a better cooling efficiency. This is something studied heavily in evolutionary biology, and it's one of the reasons humans became such strong endurance runners. But here's the interesting part. We didn't lose hair everywhere. We kept it on the scalp, and that was far from random. So, let's see why exactly. Imagine you're standing under that direct sunlight for hours. And one of the worst places to absorb heat is the top of your head. Because underneath that, well, I think we all know, is your brain. And the brain does not handle heat well. It's like a computer, you gotta keep it cool. Even small increases in temperature can affect how it functions. So instead of removing hair completely, evolution kept it where it actually mattered. Hair on the scalp acts like a kind of buffer. It reduces how much direct solar radiation hits your skin. At the same time, it doesn't completely block airflow, so sweat can still evaporate. Some research even shows that tightly curled hair creates more space between the hair and the scalp, which helps reduce heat transfer even more. That's why scientists think hair texture may have adapted in part to climate. It's not just aesthetic, it's functional. So now you've got this system where your body cools itself through sweating, your scalp is protected from direct heat, and your brain stays within a safe temperature. But there's another piece of this system that doesn't get talked about as much, and that is the oil it produces. Now, before we get into that, you may be asking, well, how do bald people survive? Or at least I'm asking. So I did some more research, and, well, the hair is essential, but it's not essential. The brain is protected by the skull, obviously, layers of tissue and fluid, and a very effective blood circulation system. Blood flow actually helps carry heat away from the brain, acting like a cooling system, so even if your scalp gets hot, your brain temperature is still tightly regulated. Now, hair helps a bit with shading, but the main cooling system is sweat. Humans rely heavily on sweating. When sweat evaporates, it removes heat from the skin. And a bald scalp can actually cool faster in some situations because there's no hair blocking evaporation. So while hair reduces incoming heat, being bald can improve heat loss. It's a trade-off, but not really a dangerous one. The hair is like a passive layer of protection, but not a critical survival system. The real downside of being bald isn't overheating. It's all these TikTok trends of people running up to you, yelling Michael Jordan, trying to grab your scalp. No, I'm just kidding. It's sun exposure. Without hair, the scalp is more vulnerable to sunburn, UV damage, and increased risk of skin cancer. That's why bald people often have hats or use sunscreen to help the scalp. But let's get back to the main points of the video. Shout out all the bald people. Now back to why our hair gets oily. That greasy feeling that you get when you don't wash your hair for a little, that's not a flaw, that's your body doing exactly what it's supposed to do. Your scalp produces something called sebum. It comes from sebaceous glands that sit right next to your hair follicles. And yes, in modern life it can feel annoying, but biologically it's doing a lot for you. According to research in dermatology, sebum helps keep hair from drying out and snapping, maintain the skin barrier on your scalp, protects against bacteria and fungi, and even provides a bit of water resistance. It's basically a built-in conditioning system. Without it, hair would become brittle very fast, especially in harsh environments. And from an evolutionary standpoint, this matters because long hair is only useful if it doesn't break constantly. So hair and oil didn't just randomly exist, they evolved as a system. Quite amazing if you ask me. Now let's get into why hair looks so different from person to person. A lot of that comes down to hormones and genetics. Hormones like testosterone, more specifically androgens, play a big role in how thick your hair grows, where it grows, and how it changes over time. That's why hair patterns shift during puberty. It's also why some people experience hair thinning later in life. Genetics control things like curl patterns, density, growth speed, the color. So when you look at a different hair type around the world, you're not just seeing random variations, you're seeing traits that developed over time, often tied to environment and adaptation. Now, with time, at some point, hair stopped being just about survival. It started becoming information. We are really good at reading visual cues, even if we don't realize it. Hair can signal things like overall health, nutrition, age, hormonal balance, all sorts of things. In evolutionary psychology, there's a lot of discussion around how physical traits that signal health tend to become attractive. Hair fits into that pretty well. It's visible, it changes based on condition, and it's hard to fake long term. So over time, hair becomes part of how humans assess each other, not consciously, but subtly. Then culture enters the picture, and everything changes. In ancient Egypt, people often shaved their heads entirely. It was practical, cooler, cleaner, fewer parasites. But at the same time, they wore wigs that could be incredibly detailed. So even when natural hair was removed, the idea of hair as identity stayed. In ancient Rome, hairstyles became more elaborate, especially for women. Hair could signal status, wealth, even political alignment. Across different periods in Europe, hair has been tied to religion, class, and social expectations. At different times, it meant modesty, power, rebellion, conformity. Hair stopped being just biological, it almost became symbolic. So, in today's terms, how do we use hair? Well, people mostly use it to express their identity, creativity, and culture, things of that sort. You can shave it off completely, grow it long, you can dye it any color your imagination wants. And the interesting part is, all of that sits on top of the same biological system that evolved hundreds of thousands of years ago. Nothing about the core function about it has changed, just what we do with it. Now, if you zoom out, hair is kind of a perfect example of how human evolution works. It started as a survival tool, something that helped regulate heat and protect the brain. Then it became a signal, something tied to health and perception, and eventually it turned into cultural. Identity, expression, personal choice. So the next time you look at your hair or even someone else's, it's not just about the style, it's biology, evolution, and even our history, all layered together in something most of us barely even think about. Now let's talk about some of the points and differences of hair. Hair differences between populations mostly come down to genetics shaped by environment over time, as we said before. What you're noticing, tightly coiled hair versus straighter or looser hair, is primarily the result of how the hair follicle is shaped. Round follicles is straight hair, oval follicles is wavy hair, and flattened or curved follicles is tightly curled hair. People with ancestry from regions like sub-Saharan Africa are more likely to have curved follicles, which produce tightly coiled hair. People with ancestry from Europe tend to have more oval or round follicles, leading to straighter or looser hair. Scientists believe that this has a lot to do with climate adaptation, especially heat. In hot, high UV environments like much of Africa, tightly coiled hair has some advantages: better heat protection and the cooling efficiency. The thicker versus denser is a common misconception. A lot of people think tightly coiled hair is thicker, but that's not exactly the full picture. Individual strands of tightly coiled hair are often not thicker than straight hair. In fact, they can sometimes even be more fragile. What creates the appearance of thickness is the tight curl pattern, the way strands overlap and expand outward. So it looks fuller or bigger, even if the strand thickness isn't greater. It behaves differently. Tightly coiled hair bends more along the strand and can lose moisture more easily. That's why often it feels drier, needs more moisture, and is more prone to breakage without care. It's not just African versus European. Human hair exists on a spectrum. East Asian population often have very straight, thick hair. European populations show a wide range, straight to curly, and African populations tend toward tighter curl patterns. All of this variation comes from genetic diversity built over thousands of years. The difference in hair types comes down to follicle shape, genetics, and long-term environmental adaptation. So with all of that said, when you really step back and think about it, hair is kind of remarkable. Something most of us treat like a routine part of our day, cutting it, styling it, sometimes even being frustrated with it, is actually the result of millions of years of human adaptation. It helped our ancestors survive intense heat, it worked alongside sweat and oil to protect the body, it even became a way to signal health and identity without saying a word. And over time it turned into something even bigger than biology, culture, expression, and our personality. So whether your hair is straight, curly, coiled, short, long, red, green, purple, or even gone completely, it's still part of the same story. A story that started long before all of us, and it is still evolving in how we choose to wear it today.